Now let us find the expression for drift velocity. Okay, so in the last lecture, what we have find? We have find that Vd is equal to V1 plus V2 plus dash plus Vn divided by n. So this is equation number 1 that we have found it. Now whenever I put electric field, then what will happen? It will experience a force, isn't it? So let me write the force first. So this is force on electron is equal to is F equal to E. Okay, F equal to E and minus. Why minus? Because force, and this is my electron. We know that force is equal to QE, isn't it? But here Q is my electron. I am putting the negative sign. Why? Because electron is a negative charged particle. So if you don't understand this, okay, I have already explained all this diagram. It is in a very beautiful way. Okay, please go in the previous lecture, for which I will give the link in the description also. You can always watch that video, which is very interesting. Now in presence of electric field, there is a force. Now what happens is, because of this force, there is acceleration of the charged particle, isn't it? It was moving in this direction with thermal velocity, blue arrow. As soon as I put the battery, electric field was generated and it experienced a force. Because of this force, the particle, this electron, will accelerate, isn't it? So due to this force, what will happen? Electron will accelerate. And we know that F force is equal to mass into acceleration, or acceleration is equal to, okay, force is equal to mass into acceleration, right? Then what will be the acceleration? It will be force divided by mass. Okay, so therefore I will write the acceleration A is equal to F divided by m, which is equal to, what is the force now? Force is minus E, capital E, divided by m, isn't it? This force, or acceleration A is a minus E by m. So equation number 2. Understood? So we got the acceleration of the charged particle. Now because of this acceleration, there will be a velocity, isn't it? This acceleration, there is a force and there is acceleration and there will be a velocity. So because of the acceleration, okay, this acceleration produces, what do you produce? Velocity to the electrons. So therefore I must write the relation between velocity and acceleration, isn't it? Okay, so this is the relation between acceleration and force. Okay, because of the force, it was accelerated, and I got the relation A equal to F by m, or A is equal to minus E, capital E by m. So relation between acceleration and force I got. Now because of this acceleration, there is a velocity. Okay, v1, v2, all because of acceleration. And I should also write the relation between acceleration and velocity, and we know that the kinematic relation V is equal to U plus AT. Okay, so this is the relation between velocity and acceleration. Now this is very important. Now I will go to this time t. Okay, which is very important. Now say two things I am going to define it here, which is very important. You have to write this note. And first of all, let me see what was happened to the charged particle. So let me have this as my electron. Okay, so this electron was here and it moved with acceleration. In this fashion, and it collided with, say, one atom of the conductor. Understood? It collided with the atom or charged particle, atom or another electron. Okay, I am not saying atom only. This electron may collide with atom of this conductor, or it may collide with another electron which is flowing here. Okay, once it was collided, let it went in this fashion. Okay, so I am giving this is my electron. Now in this case it collide with the electron. Okay, now after this collision, let this charged particle, this electron, float in this direction. So this is like an atom. Okay, so this is how the electrons are colliding with each other. Okay, this is very large scale. Okay, I am just magnifying it so that you can see. So what happens is, it is going from A to B and C to D. Okay, so it is following a path. This is under the action of electric field. So what are the things it is happening? There is acceleration, there is velocity, and there is time. Isn't it? From A to B, whenever it goes from A to B, there is no collision. No collision. Okay, from B to C, there is no collision. Here also no collision. Here also no collision. Can you say this? It means that this path is no collision, no collision, and no collision. It means that here is, this is my free path, isn't it? Free path, free path, free path. What do you mean by free path? I am not saying that in this free path there is no acceleration. I am not saying there is no velocity. Yes, there is velocity as well as acceleration, because there is always an electric field in the conductor, but it is not colliding with anyone. Okay, that is why it is free path. Free path means it must have distance, isn't it? It must have distance. This is also have distance. Okay, everywhere this is also distance. Now I will define one important topic here, that is free path. Free path, or I will write this as mean free path. Please remember, please write it in the notebook, that mean free path, it is the path between, or it is the measure of distance between two successive collision. Okay, what do you mean by mean free path? It is the measure of the distance between the two successive collision. From A, B to C, there is no collision, that is free path. There is a certain distance, and there are so many distances, isn't it? In collision between charges, there are so many distances. Now if you take the average distance, okay, I am going to the deeper part. If you take all the distances and you take the average, then average is called mean free path. What is mean free path? It is the measure, or it is the average distance between all the successive collision. Average distance between two successive collision. Please check the spelling. Successive, S-U-C-C-E-S-S-I-V-E. So mean free path, it is important, is the distance, okay, average distance between the two successive collision. You take all the distances and take the average, and that is called average free path or mean free path. So this is very important topic. Now next is, I am going to have this time talk. Now there is, everywhere there is no collision, isn't it? No collision, no collision. What do you mean by no collision? Then the charged particle is relaxed, isn't it? It is relaxed. Relaxed. Again I am saying relaxed doesn't mean that it is not experiencing electric field. It doesn't mean that it is not experiencing force. Okay, it means that it is not colliding. Okay, ये एक दूसरे से collide नहीं कर रही है, so इसे कहते हैं relaxed. So charge particle are relaxed in this between this collision and relaxed, and it is also having time. It means that it will take a certain time. So I will take T1, it will take T2, it will take T3, isn't it? So it is taking some time, it is taking some time, it is taking some time in between the two successive collision without any collision. Okay, there is no collision between these two successive collision, and to pass from B to C, it is taking certain time. Okay, now see, if you take average time, average average time. Okay, we take the average time, that is equal to, how do you take, T1 plus T2 plus dash plus Tn divided by n. Okay, if you take all the relaxed time, all the time, and take it as average time. Okay, average, I will call this as relaxed time, then this will be called as tau, and which is called relaxation time, RELAXATION, relaxation time. So what do you mean? This is also very important. What do you mean by relaxation time? It is the average time between the two successive collision of electron. What it is? It is the average time between the two successive collision of electron in the presence of electric field. Okay, so tau is equal to T1 plus T2 plus T3 divided Tn divided by n. Total number of time divided by total number of observation is average relaxed time. So this average relaxed time is called relaxation time. So what is the definition of relaxation time? It is the average time between the two successive collision, and we got average time as this one. Okay, so this is very important. You have to write it in a separate paper, or you can write in any paper, but you have to write it. Okay, so this time is now my this relaxed time. Okay, now see, there are how many electrons? There are many electrons. So I will write this as V1, and I will write as U1, and okay, not V1, V2, or I will just write V is equal to U plus, okay, what is the formula of A? We have what A is equal to E, capital E divided by M, and there is minus, so I will take this as minus, and this is my T. Okay, now if you see here, whenever there is a charged particle, when it is moving, E will not change. Okay, charge will not change. When it is moving, electric field will not change in the conductor. Mass will also not change. It means that A is constant. Okay, so in all the case, A, that is acceleration, is constant. You have to make this point. Okay, acceleration during the flow of charged particle is constant. It is not changing because we got the acceleration as E by M. E is charge, which is not changing. Electric field is also not changing, and mass of the charge will also not change. That is why acceleration this is constant. Understood? This is constant. Now there are how many charges? There are so many charges. What? There are so many charges, isn't it? So now for therefore there are many charges. There are many charges or electron. Therefore, there will be V1 will be equal to this, using this. Okay, U1 minus E, capital E by M, and T1, and V2 will be U2 minus E by M, T2, and so on till Vn is equal to un minus ee divided by m Tn. Okay, so this is for charge 1, electron 2 and electron m. Now I got V1, I got V2 and I got Vn. Then I can get the value of drift velocity using equation number 1. Okay, so therefore Vd will be equal to how much? V1 is my U1 minus E, capital E divided by M T1 plus V2 is U2 minus E, capital E divided by M T2 plus dash. Then plus what is there? Vn, that is Un minus E, capital E divided by M Tn. Okay. Then I will take whole divide by what is there? M. Right? So this is my drift velocity. Now let me solve it more. Let me solve it more. Let me take the common. So U1, U2, I will take U1 plus U2 plus dash plus UN. I will take one common. And what is there? There is minus, this is minus E, capital E divided by M. I will take common, then what will remain? Okay, you can do one more step just below this, just like terms. Okay, let me write it here. I will just write U1 is there, then plus U2 is there, then plus dash plus U1 is there, isn't it? Then what I have here? I have minus, then what I write? E, capital E divided by M T1, again there is minus E divided by M T2. Okay, so I need this one. I need this tau is equal to T1 plus T2 plus dash plus Tn divided by N. I need this later. Okay, then what is there? Minus E, capital E divided by M Tn, and this is whole divided by N. Right? Now what I can do is, or I will write Vd, or Vd is equal to, you make it 1 U1 plus U2 plus dash plus U1 separate, and what is there? There is minus, and there is E divided by M, not E, small letter E, capital letter E divided by M, and take the common. Okay, whenever I take the common, I will rub this out. If I take the common, what do I get? I get T1 plus T2 plus dash plus Tn, and this is whole divided by N, isn't it? So this is whole divided by N. Now we are almost done. I will separate U1 plus U2 plus dash plus Un divided by N, capital N, sorry, small letter n, then minus E, capital E divided by M, then T1 plus T2 plus dash plus Tn. This is done now, and divided by N. Right? Now, if you see here, what is this? U1 plus U2 plus U3 plus Un will give me 0, because this is my initial average velocity. This is 0. Why? Because this is average thermal velocity, and average thermal velocity is 0. We have done in the last lecture. Okay, again I will okay, I can explain this, but not now. And this is equal to how much? This is equal to tau. So I will get, or this Vd is equal to minus E, capital E divided by M tau. So this is the relation of drift velocity. This term will give me tau, isn't it? I am taking the average of all the relaxed time between the two successive collision, and this is my tau, which is called relaxation time, and this is my drift velocity equation. Now what does this negative sign means? This negative sign means that the direction of velocity is opposite to the direction of electric field. For an example, you have this conductor. This is positive and this is negative. Electric field is in this direction, but the force on electron is in this direction, isn't it? And velocity is also in this direction, right? Because force is always in opposite direction to the direction of electric field if the charge is negative, and the charge is my electron, which is negative. So force is opposite. So negative sign represent that velocity is opposite to electric field. So this is all about my drift velocity. Thank you.